Hello, this is MR Engineering, and I will be introducing the application of our lighting control system. The goal of this presentation is how to apply our system for the purpose of design, creating database, installation, programming, and to better understand our system. This presentation will cover concept, energy saving and payback strategy, application and design, configuration of database, installation, and programming. Firstly, I'd like to discuss the concept of lighting control. The cost of electricity for a larger building is obviously a major concern. Implementing our lighting control system can reduce the lighting portion of the lighting electricity bill up to 50%. It provides a comfortable and pleasant office environment for the occupants and thus increases productivity. The lighting control system, an intelligent building, is for saving energy and for convenience. It is an essential factor for management. Lighting control is a widespread energy-saving strategy for today's society. For saving energy, our lighting control system is separated into three basic strategies: occupancy sensor, time schedule, daylight sensor. Additional strategies include group and pattern control, lumen depreciation compensation, demand control, astronomical control, scene control. In addition to the strategies above, we at MR Engineering are continuously creating new ideas for saving energy. MR Engineering products for lighting control solutions include intelligent lighting controls, economy lighting controls, smart touch switch, dolly ballast, dimming controls. The key features of our latching relay systems. After an instant blackout, it keeps the previous status prior to the blackout. There is no wasted electricity. Life cycle 100,000, 20 to 30 amps. Many other companies don't have these vital features in their relays. This is one of the key elements for a dependable lighting control system. From a building owner's perspective, installing a lighting control system initially is a large investment. Therefore, they might hesitate to invest in a lighting control system. However, when calculating the energy usage of your building, the initial investment will pay itself off within 2 years, and by the third year, they will be saving a substantial amount of money. At this point, we'll design a sample building as an example for installation and programming. For designing a building with lighting control, we must consider the following: programming according to the building type, zone separation, window side pattern control, open area, and control by each sensor. Select the lighting control device and lighting control panel for each floor, create the database, LCP and switch, etc., ground design and 3D design, system block diagram, and panel schedule connection diagram. We're going to design and configure a gymnasium and a 5-story office building with a basement. Our design will incorporate a conference room, elevator, CEO room, and an open-spaced office area. The 5th floor is configured with 2 security lights, which are 1 kilowatt each. The gymnasium is configured with 4 relay zones for basketball, volleyball, etc. The stage is configured with 1 relay zone, and seating areas configured with 4 relay zones. There are a total of 9 zones. To use our lighting control system, I will first define the control concept for each zone. In the office building, the office zones from the 2nd floor to 5th floor is identical. The elevator hall, conference room, CEO room areas are separated by 2 relay zones. The open office area is a 4 relay zone, and the window side is a 2 relay zone. The 1st floor and basement is configured with 12 relay zones. Due to the security lighting on the 5th floor, an additional zone is needed, as well as 13 relays as opposed to 12. Basement to 5th floor needs 1 LCP 12, and again the 5th floor needs an additional relay. There are two photo sensors installed at the window side of the second floor and fourth floor, and each photo sensor is capable of controlling up to 3 floors. Additionally, floors 2 through 5 have one occupancy sensor in the CEO room and one occupant sensor in the conference room. Each floor has 4 switches, 2 8-button switches, one 1-button switch, and one 2-button switch. The gymnasium is configured with 9 relay zones and it needs one LCP. Therefore, the LCP is configured with 12 panels for the gymnasium. Now let's look at the configuration called system block diagram, which you can see in the picture above. We need to configure each switch, sensor, and lighting control panel. This will be installed right next to the lighting distribution panel in the electrical room, and the lighting control system that contains the communication unit, printer, and computer, which will be positioned in the central station. The lighting automation panel is the configuration list for each lighting control panel. This is the organized information for control board types, and it shows the quantity of relays for each lighting control panel. The connection diagram is the basic wiring method design. After defining each lighting control panel for each floor area, we need to organize the database for each lighting control panel. This can be used for the basic information of each lighting control panel, such as the quantity of driver boards, card for lighting control, name of lamp panel circuit, names for location of each relay, and the addresses for lighting control panel. We need to make sure the database is defined correctly for the switches. Additionally, the database serves the purpose of defining operation of the relays and sensors. This is the time schedule control for defining which relay is controlled by the user program time zones. Additionally, it's used to manage the efficiency of lighting management and energy saving. The astronomical time clock function has a sunrise-sunset time zone control. This function can be set using the select location drop-down box pictured above. When each switch is connecting to data line, it is defined which switch button is operating which relay. In the gymnasium, the scene control function is the best option for lighting control. Unlike the office area, it is not controlled by certain time zones. It is operating intermittently for games and stage use. To apply the scene control function, configure the zones first, and then configure the circuit available for the scene control. Use the time function when there is an event. Select the scene button by switch at the specific zone area or central monitoring panel. For installation, each device of our system should be installed according to the order defined below. Install enclosure, piping and cabling, install the lighting control inner panel, connection. First, we'll install the enclosure of the lighting distribution panel and lighting control panel. The piping and cabling can be installed after the enclosure is installed. After the piping and enclosures are installed, we are ready to install the cables. The picture above illustrates how to install the cables. After cable installation operation is complete, we need to mount the board with the relays. The picture is the connection diagram for connection between the sensors and switches and also the lighting control panel electrical room and central monitoring device. We can program the software before or after the hardware is installed using the blueprint and database. Our software is divided into 6 sections, and when programming, follow the order below: user ID and level setting, communication setting, configuration of database, program and downloading, graphic editing, report. First, we're going to set the level, password, and ID for the programmer. Second, we need to set the communication of the local lighting, control panel, and the computer of the central monitoring panel. Third, we need to configure the database using the data from content configured inside of the Smart TLC software. Fourth, we need to create and set the database for each program. The picture above shows the time schedule control program. However, there are several program types. This picture shows the astronomical function programming sheet to calculate the sunrise-sunset time schedule. This picture shows the graphic editing function. The graphic editing is easy and convenient by just using the mouse. The picture above is the object property screen for configuring more detail to each graphic screen. Our Smart TLC software has powerful report function. The event report indicates the content whenever status change occurs. The user can select Disable Status to save paper when this function is not needed. Smart TLC has various printing functions such as runtime, data log, etc. User can convert to printout form by MS Excel.